Moving on with 9.3, which starts on 566. This time around, we're looking at string methods the same way we did at character methods. Now, I'm going to cover this the same way. I am not going to insult your ability to read. What I am going to do, rather, is just highlight those methods that I think you will already have felt a need for just in completion of the end of chapter exercises and in completion of the program challenges and in completion of just you going through and investigating the topic. So these are string methods that are part of the wrapper class for the string object, and these methods are ones that you are probably going to find will have value to you, not just here for class, but when you are working with data coming in, from a user again or from a file. What you're going to want to do is parse out. You're going to want to grab sections of a string for their value and potentially even throw away other parts of a string for their lack of value. So the easy ones here, this is table 9.3, do exactly what it is that they sound like. So again, this is 566. The starts with method. What you do is the Boolean version of starts with, rather, will return true if a string was passed to it, and it will return false if no string was passed to it. So whether or not that's going to be of immediate use to you is debatable. But if you want to make sure that the element that you're passing to a function someplace is in fact a string element, this is actually pretty useful. Ends with, Boolean ends with does exactly the same thing, but at the other side, so the back end of that string. Region matches. What you would do is you would compare a string with a starting value someplace. So essentially what we've got here is Boolean region matches, and inside of the parentheses we have an integer. That integer maps to the character number that we want the search to begin. After the comma is the string it is that we're looking for. After the comma again is the second string we're going to look at. So this is like a compare regions of two different strings. So the same deal. We indicate the string that we're looking for, and we indicate the integer of the starting point it is that we're looking for there. So if we're, we need, after the first three characters, AAA, the part number is going to say screw, or the part number is going to say bolt, or this part number is going to say nut, or the part number is going to say wing nut. What we can do is match that region. So we would say, start at character 4. We would go for, if we're looking for bolt, we would go for 4 characters from there, and then we would look for the following string, BOLT, and it returns true if the region matches that. So it's nice when you're looking at a range of data and you're trying to compare, or you're trying to rather parse out whether or not this string, if it was entered from a user or if it was read in from a file, we want to know if this string contains a portion of text that we're looking for. There is also an overloaded version of this, and we're going to see overloaded again in a little bit here with another string wrapper class method. Essentially what overloaded means is it has the same function name, but we have a different list of parameters that we pass to it. So you'll notice the new wrinkle here is we have ignore case. So, and again, I'm not going to describe that to you because I know that you know what that means. But this time we're going to ignore case. The previous version of region matches did not ignore case. So if we were looking for capital S screw and the range of values had, or the range rather of characters had lowercase s for screw, that is not a match. This one, on the other hand, the overloaded version with ignore case as a parameter, does return true because it's going to do what it sounds like. It's going to ignore the case there. As we continue on through the chapter here, the next is for searching for a character. This begins on 569. We can return the index of a character from a string, so that does exactly what it sounds like. We can return the index of a character someplace from within a string. So if we give a second argument here in that overloaded index of method, we can indicate what element of our string, so it's just an array of characters, we can indicate which element of that string we want to start at. So we want to find the index of a certain letter, let's say the next A, because the next A is going to be capital AAA. Again, that goes back to our part number. So we can say start looking after character 3, so character 4, because the first 3 characters are always AAA, and we don't need to return that. We can return the index of an entire string, so not just a character. The last index of is exactly what it sounds like. It's the last time a character shows up in a string. The overloaded, that's the word I'm looking for here. The overloaded function for that includes int start, because we would pass to it an integer that we want to start at. So the same thing as the previous example, ignore the first 3 characters, start at character 4. And that's it. So when you're working with data, those may come of value to you. There is an example of the index of, so this very first one here on 569. There is an example of index of in the homework, just so that you have something to look forward to, if that's what you want to call that. The very last piece here that I actually think you will find the most immediate and the most long-term value in is here, table 9.5 on 572. It is returning or extracting parts from a string. So we can, return a range of values from within, or a range of elements rather, from within that string. And it sounds and works exactly like it should, right? So if I want to remove screw and whatever the next characters are after that in a string, I would say string substring here, and int start would be 4 because that's the number of the character that I want that substring to begin at. I'm going to let you go through the rest of these. They are almost exactly the same. It's just that we can specify a beginning range, an ending range, and a character with which we want to remove from there. So those are all really, I'm happy to report, very, very self-explanatory. They do exactly what they say they're going to do, is remove a string or return a string, or return a range from a string, or remove a range from a string. It's pretty straightforward. Lastly here, we have the idea again of concatenation. We have been doing this the whole while inside of a print line or a print method call. Anytime we have the plus operator in there, what we're essentially telling Java to do is concatenate. Add to the end of whatever was previous the thing that we are doing here. So when we concatenate 2 strings, so if I have rock and valley, so string 1 is rock and string 2 is valley. When I concatenate them into string 3, what I do is take rock and then immediately thereafter put valley on there. So it goes with no space indicated. It's going to go rock valley as one word, and we're going to store that value in string 3. So concatenate does that for you. So concat is the shortened version of that, and it simply puts string 2 at the very end of string 1. There you go. We can replace characters from within a string. Let me please warn you about this one. Is anybody who's been developing for a while, or anybody who's worked with data for a while, or anybody who has coded even just the homework like you guys have, I think everybody has done this, where we've said to ourselves, okay, wait, I want to find and replace all references to the following because I know I don't need it anymore. So I want to take all cat and replace it with dog. So we do the brute force Control G or Command G if you're on a Mac. We do the find and replace, and we say cat in the find, and we say dog in the replace. And now we've broken something substantial, because now in my code, where I had all references to CAT, I now have DOG. So I've already made a problem right here. I don't concat anymore, I dog, or con dog rather, and that's a problem. Let me please warn you, so you don't step in it as majorly as maybe you otherwise would have an opportunity to do. Make damn sure that if you are going to take a string and replace every instance of a character in that string, that you have worked your logic for that particular method to a T, so that you do not remove all instances of cat, and then you have con dog as a function call, which will return a compilation time error from Java, which will force you to go back and replace that. Now that's actually going to go really quickly. You're going to see that and you're going to go, yeah, of course, that's the case, right? The problem with working with data is you may not discover that logical error you made until way down the road. So I really hesitate, even now. Anytime it is I do a find and replace, I go through the whole list of data. I go through the whole list of code. I go make sure that I'm not making one easy to overlook error in replacing wholesale characters or strings from within a character. So that's my very, very lengthy word of caution on replace. The next one here, trim, is fantastic. You simply pass to trim a string that you want to remove all the white space from. So white space is a value rather, to you and to me, right? So when I have the quick brown fox jumped over the lazy yellow dog, in between each of those words I would have white space. And that's valuable for you as a human reader. But potentially, it's just taking up space. Potentially, we don't need that for Java to be able to do its job with the data on the other line, or on the other side of that. So what trim allows you to do is return a copy of a string with all the white space stripped out, so that now you have a much smaller string that you can use someplace else. So that one doesn't feel as useful until you've started working with big blocks of data. But just remember, just park it in the back of your mind someplace. Trim is going to be of value to me someplace down the line. The very last things here, value of, here we go. We have been using value of in one form or another with primitive data types all this while, right? So where we have, where we're looking to receive as an input from the user, where it is that we're looking to receive an input, we would have, next double, next int, so on and so forth. That's very similar to what we're seeing here, right? We were forcing in those cases next int, next double, next char, next float. We were forcing in those cases we were forcing Java to make an assignment based on the type that we were specifying there. So when I say next double, that tells Java, oh, the value that's coming here is a double. So even if the user puts in 100, I am going to, I being Java, the runtime environment, going to convert that to a double .00 afterwards. Or even if the user certainly is putting in 100, if I get a string from that, I will put that as a string as opposed to as numeric data. Now, we've done the opposite of this before. We have taken numeric data and put it into a string container. This time around, we're going to take a string or we're going to take and save into a string those values that we would read as numeric data. So you'll notice again that these are overloaded functions. So just as a reminder, what does overloaded functions mean? You'll notice I have value of, so my first method for a Boolean, value of, my second method for a char, value of, my third method for a character array. I have value of double, I have value of float, I have value of int, and I have value of long. It's the same method name. The only difference there is the parameter that we pass along. So that is doing exactly what it sounds like. It is returning a string representation of a primitive data type, float, character, integer, etc. So those can be valuable to you when you know you're not necessarily going to do math with something. If you're going to get address data from a user, you're not going to do math with that necessarily. So there might be reason for you to store addresses exclusively as strings, even if for whatever reason they are passed to you in the form of data as integers. So there are a host of valuable string methods here in 9.3, and I think that all of them have, you have wanted to see those at some point in time, and now you're finally getting an opportunity to do so.